Okay, so we need to talk about definite integrals and what happened when you do substitution with it. You know that for definite integrals, you perform this procedure exactly the same as the indefinite integrals. It's just that at the end, you have to evaluate. You have to do f of b minus f of a. When it comes to u substitution, remember, everything has to be in terms of u. A and b are in terms of x. So when you perform u substitution, you let u be g of x, then du will be g prime of x dx. A and b have to also become what they are in terms of u. So what you do is you plug in a for x, you get g of a. Plug in b for x, you get g of b. If you want to say these two are equal, that is the only way you can do this. You cannot keep this as a and b and then say they're equal to each other's, because they're not. Okay, the number here are what u is supposed to be. If you use the x number, unless they're the same, otherwise that is not equal. Okay. Once you make that change, for definite integral, you don't have to go back to x. All you need to do is plug in these two numbers to whatever the integral is. F of g of b minus f of g of a. With that in mind, give this integral a try. The integral from 0 to 2, x times square root of x squared plus 1 dx. Pause the video and see what you get. Okay, so in this example, we have a composite function, square root of x squared plus 1. So we try let u be x squared plus 1. du is 2x dx. And that matches with what we have in front. With the extra 2, divide that over. Du over 2 is x dx. If you need to write these out, I would do it. When x equal to 0, u equals to 0 squared plus 1, which is just 1. When x equals to 2, u equals to 2 squared plus 1, which is just 5. So this integral is now the 1/2. Let's put that in the front. The integral from 1 to 5. X dx is now du, well, over 2. But we have the over 2 in the front already, so we're good. And then this is u, so we have u to the 1/2. And now we proceed as normal. 1/2, u to the 3/2, divided by 3/2. Or as I said before, multiply by 2/3. Evaluated at 1 and 5. Okay. So let's see, 1/2 times 2/3. We can simplify that later. 5 to the 3/2 minus 1 to the 3/2. That's just 1/3. 5 to the 3/2 minus 1. And that's it. Definite integral, change the bound. Do not go back to x. If you do that, it is very straightforward. If you don't change the bound, do not say they're equal to each other's. Okay? You want to do it as an indefinite integral first, and then at the end, plug back in a and b. Okay? If you change the bound, do not go back to x. Okay? So if you change it to 5 and 1, do not write x squared plus 1 back in. And keep them in 5 and 1, because then you're mixing x and u together once again. Okay? So those are the common mistakes that people do when it comes to definite integrals. And hopefully after this, you will be able to avoid them.